Now in this video we are going to look at the discriminant. Okay, again another big word, but don't worry, it's not really that difficult. I just quickly want to get back to the formula for just one moment so that I can show you something. So our formula, the quadratic formula, minus b plus minus the square root of b squared minus 4ac over 2a. Okay, now you'll remember that this is when we have a quadratic equation, ax squared plus bx plus c is equal to 0. But we did say that a quadratic equation can have different types of solutions. We can, for example, have two solutions, okay, or we can have one solution, okay, only one x to solve this equation, or we can have no solutions, 0 solutions. Now the discriminant is what is going to tell us about the nature of our roots, okay, the nature of the roots. Now what on earth am I talking about when I say roots? Well, roots is just the solution of an equation, the solution, okay, the nature of the solution. Okay, so what in my formula is going to give me some guidance on whether I'm going to have two solutions, one solution, or no solution? Well, it is going to be what's underneath the square root. Okay, you'll notice that if it is the case that b squared minus 4ac is greater, less than 0. In other words, when I substitute and I get a negative number, then I won't be able to find the square root of that number, which means entering this into my calculator, I won't get any real answer. So if that is negative, it tells me I will have no solution, no real roots. Okay, no real roots means I won't have any real numbers as a solution. Okay. Next up, you notice that this is the value that causes my answer to have two, or my solution to have two answers. And the reason why is because I'm adding it for the one and I'm subtracting it for the other one. So if I find that my square root of whatever is inside is equal to 0, in other words, if it is the case that b squared minus 4ac is equal to 0, then the square root of that will be equal to 0. Then I'll be adding nothing and I'll be subtracting nothing, so all I'll have is negative b over 2a. Okay, which means only one answer, because I won't have anything to plus and minus. So if it is equal to 0, then I will have one solution, one real root. Okay, and that root will always be rational. Okay, remember rational numbers? Okay. The next thing is if that value that's inside the square root is actually a square number. You remember what square numbers are? Okay, so if b squared minus 4ac is a square number, that's a number like 2, 4, 9, any number that I can find the square root of easily. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. These are square numbers. Okay, if I do get a square number, then I will have two rational roots. Two rational roots. Okay, two rational solutions. And finally, if b squared minus 4ac is any other number I will have two irrational roots. So let's have a look at a few examples, okay, and why not just stick to some of the examples that we've been looking at before. For example, we had x squared minus 16 is equal to 0. And here we notice that a is what's in front of the x squared. A is equal to 1. B, there's no x term, so b is equal to 0. And c is equal to negative 16. So what do we get when we work out the discriminant? Now the discriminant, this b squared minus 4ac, is given the sign delta. It's like a little triangle and it's called delta. So delta is equal to b squared minus 4ac. And if we calculate it for this one, we see we get 0 squared minus 4 times 1 times 16. Okay. So 4 times 16, and it's not just 16, it's negative 16. And we find that the answer is 64. 64 is not less than 0. It's not equal to 0, but it is a square number. The square root of 64 is equal to 8. So it's a square number, and therefore we will have two rational roots. And do you remember what those two roots were? They were x equal to 4 or x equal to negative 4. Okay, let's look at another one. The other one we had a look at was x squared plus 1 is equal to 0. And you might recall that we couldn't find two brackets for this one. Let's see if it even has any roots. Well, we do the discriminant is equal to b squared minus 4ac. Our b, again, we don't have an x term, so there's nothing in front, is 0 squared. Minus 4 times a is what's in front of the x squared, is 1. So 4 times 1. And c is equal to plus 1. So 1. If we solve this, or simplify this, we get negative 4. Here we notice our discriminant is indeed negative, less than 0. So it will have no real roots. Okay, it's impossible to put this into two brackets. Next up, let's look at x squared minus 2x plus 1 is equal to 0. So our discriminant equal to b squared minus 4ac. This time our b is equal to negative 2. Negative 2 squared is equal to 4 minus 4 times a is equal to 4 times 1 times, and c is also equal to 1. And what do we get? 4 minus 4. 4 times 1 is 4. So we get 0. And we know that when it is equal to 0, we have one real root. And you'll remember that this one's answer was x is equal to 1. Let's do one more. Okay. Now last example, we had a look at 4x squared minus 3x minus 7 is equal to 0. And our discriminant equal to b squared minus 4ac gives me b is negative 3. Negative 3 squared is 9 minus 4 times 4 times negative 7. And if we calculate this, we get 121. Again, 121 we can take the square root of, and therefore it will be this one where we have two rational roots. Finally, let's do one more. Let's look at 3x squared plus 2x minus 3 is equal to 0. Then our discriminant is equal to b squared minus 4ac. b squared is 2 squared is 4 minus 4 times 3 is 12 times negative 3, so this becomes positive 36, and this will equal 40. And we know that the square root of 40 is not a known number. Okay, so one last thing that I will say is that this one will have two irrational roots. Now the only time we can take a quadratic equation like this one and make two brackets, in other words factorize the left hand side, is if we can have one real root or two rational roots. In other words, if it is equal to 0 or if it is a square number. So if it is a quite difficult one, before you attempt to put it into brackets, first calculate the discriminant, because the discriminant will tell you, does it even have brackets? And if it does have brackets, how many brackets will there be? Will there be one bracket squared, or will there be two different brackets? And it can also tell you if it can go into brackets, but the values are actually not rational numbers. It's irrational numbers. That would be impossible to put in two brackets. Okay, well, good luck. I hope you enjoyed this lesson, and next up we're going to third degree polynomials. See you there.